speaker is Matt Trout. Is well known, I think, from Catalyst Moose
Mm,
DBX
bits and
class.
pieces.
But he's talk about Devops Logique today. So you float him up.
uh, Devops Logique, or why I hate it when we let the French name things. I will explain that in a minute. So back, before I even first turned up on IRC and ran into the actual Perl community, I used to kick about around, there was a site called infrastructures.org, which had a few interesting bits on it, but it had a mailing list associated with it, where people used to talk about systems automation, whatever. Back when I first ran into this stuff, CF Engine and BCFG were basically what existed. I think it was BCFG2. I tried to avoid knowing about that part because it was brilliant but insane. I mean, this was the state of configuration management circa 2002. ISConf. ISConf was what the guys who actually set up the site had built, which was actually really clever in that it was systems automation, almost, right. In the modern day, when people are doing sort of cloud servers, often you have basically a base image, run some commands on it, that's your thing. If anything ever changes, you start again from scratch. I mean, this is effectively how Docker works, for example. And ISConf actually followed that model. It was configuration management with only 2 commands. You had snap, which was basically stick this file on the machine, usually in /tump or something, because we just need it for a minute. And exec, which was now run this command to do something with it. And that was kind of interesting. And then Luke Caney started talking on there about the ideas he had that eventually led to Puppet. Something that continues to entertain me is that he'd been writing Perl previously, switched to Ruby for Puppet because he wanted better built-in OO. And then now, every time I try and switch to Ruby, every time I try and play with Ruby, I go back to Perl after half an hour in disgust because in the age of Moose, Ruby doesn't have good enough built-in OO. So, oddly, Catalyst's main REST support was written by a guy called Holloway. And the reason he was writing it was to build a configuration management inside a finance company he was working at. His goal being what he referred to as single copy nirvana, which was basically the idea of single point of truth for all of his systems configurations. And then when he started working on version 2 of this as a consultant doing sysadmin stuff, I still remember the crying on the Catalyst IRC channel because all of his customers were Rails startups. So in order to make it comprehensible to his customers, he decided as a business he needed to have the user-facing syntax be Ruby rather than Perl, which, well, it seems to have worked out pretty well for him. You may have heard of what he wrote. I had a lot of fun arguing with the details of configuration management with Holloway in the run-up to that. I would like to think that some of the things Chef does better than Puppet are at least partially influenced by those discussions. But you know what? Whether it was true or not, it was several days of really fun arguing with somebody who knew what they were talking about. And you know what? That's a joy in and of itself. I'm sure we all agree on that. But one of the things I could never quite get, I've got better at explaining this because I've had like years of fruitless arguments about it. But the whole thing about ownership, configuration management systems, at least the current set, generally want to own your system. As in, fundamentally, your final machine configuration is kind of the incidental result of this initial configuration. And that's fine in a lot of cases. Works great for, I need a fleet of production servers, I need them all to be the same. The reason, I am still convinced that the reason, other than the fact that I didn't explain it that well, but one of the reasons why I never managed to get Holloway to kind of get his head around what I was saying was, he'd come from finance. From his point of view, anybody making a manual change to a system was an HR problem. And I can totally agree with that idea, but it runs into a slight problem, which is dev servers. So many environments I have worked in run into this, because what you have is configuration management wants to own the system. That works fine for your production servers. But the dev server, you want to be able to tweak stuff to find out what's going on. And there is nothing quite so upsetting as being halfway through testing something out and having the configuration management come along and reset the server back to where it was before. So what ends up happening is people turn it off on the dev box. And now dev and production are diverging. And it just drives me insane. The host file is my critical example of this. Sometimes, to test something, you want to whack a line in the host file. You do not want your configuration management to go, that's not supposed to be there, delete, but they all do. And trying to figure out how to solve that problem in a way that still made configuration management capable of converging the system to the right place led me down all sorts of strange and crazy paths. Like the fact, and the other one that drives me insane is, make has -n. -n is, don't do anything, just tell me what you're going to do. This is wonderful. None of the configuration management systems can effectively express what they're going to do. And it drives me mental. And overwriting files, yes, this is fine on a box where you own the file. But I want configuration management that can say, is this mine? If it's mine, as in if it's the last version I installed, totally cool, I can overwrite it. If it's changed, yes, overwriting it is an option, but there are other options, like leave it alone, or, you know, for the finance environment, raise a ticket with HR to fire the person who changed it. Because tickets are a valid form of automation in a lot of respect. You know, if you're dealing with real hardware, somebody has to go and rack the thing. And software cannot rack a server yet. Okay, yes, cloud, not the point. I also ran into Nix. Nix is fascinating. If you've not looked at it, please look at it. It's really cool. The idea of Nix is to be a pure functional build system. So it has an expression language, and the idea is you treat your installed package as this is the result of this function called with these arguments. So you manage to push sort of functional programming advantages into something that is normally, you know, very much, you know, mutable state because well, it's the disk of the server. It kind of has to be mutable state. Nix is a brilliant idea. You end up with a situation where all of your builds know what they depended on. So you can, if you have the idea of a closure, which is, a Nix closure is basically, this is the build and all the things it was built against. They're indexed by, I think it's SHA-1, because, you know, as Linus Torvalds taught us, SHA-1 hashes never collide. Every time I look at that, I go, they're going to collide one day and I'm going to hate everything. And then I go, but you know what? They haven't collided yet. And this works really well. But the thing is, Nix still has a channel. which is basically a blessed set of versions of software, which is what gets built and installed. And so the channel still requires human curation. And the channel is still effectively mutable state. And I was kind of like, nice, but you missed one of the interesting challenges, which is the idea of you can do a lot more automation in dependency resolution than you think, provided you have the metadata. I think part of this is most packaging systems don't have that rich a metadata system. It's notable actually that these days the CPAM meta spec is really nice. We even have the capacity to specify conflicts. So I'm assuming at least some people in here are aware that after installing Moose, if you run Moose-outdated, it will tell you what extensions need upgrading to continue working. That's conflict information. Currently, it's a semi-manual process because you run a second stage after you've done your base install. But the information is there. But you get into into more interesting stuff once you start thinking about dependency graphs rather than just a single package. So, okay, let's say package X needs 1.1 of something, and then package Y only needs 1.0. So that's fine. You can just merge those requirements and say, I just need 1.1. But if there's a bug in 1.1.12 that breaks Y, you now have a slightly more complicated situation. So at that point, what you want is something that can go, well, in that case, we should install 1.1.11 because that's fine for X and doesn't trigger the bug that will break Y. But then as soon as you start looking at that, you run into the thing of, this may mean that for different pieces of software, I need multiple copies of the same package installed at once. And this is the point where all existing packaging systems go, I hate you. DPKG just doesn't support it at all. This is why you have the whole Debian thing of having Postgres 9.1 as the package name, and then they have a Postgres meta package that sits on top. It's a beautiful way of doing it when given you only have in Debian a few things that really need that. It's a great workaround, but I really kind of wish it was baked in. I actually started talking to the DPKG core developers with a view to maybe I could hack this feature in. They were not particularly interested, and I know exactly why. The reason is they had previously run into an idiocy problem. This is one of the fun things about open source. You know, open source is made of people. This is both the best thing and the worst thing about it. In this case, several years ago, somebody had turned up and gone, support for multiple versions in DPKG would be really cool. And a couple of people went, yeah, that might not be a bad idea. And he went, and therefore I will implement it. But at the same time, because I have decided that I am right, all Debian packages need to be renamed to follow a different format to fit my vision of how multiple versions will work. No! So when I was trying to sell them on the idea of the patch for just the multiple version support, they were having flashbacks to this Muppet and assuming that basically anybody who wanted what I wanted would also then end up wanting all of the stupid shit he wanted. And they really weren't that interested, and I do absolutely understand. If I'd had to deal with the previous idiot, I'd probably have been a dick to me later too. Interestingly, when I did a survey of all of them, RPM, provided the packages don't share files, RPM's fine with it. It actually handles it. It handles it perfectly. None of the tools built on top of RPM do, because nobody's ever actually thought about that. But RPM handles it. But I didn't consider this to be a suitable final solution for the reason of it's RPM. I mean, really? Um, so another thing that was fascinating, BPEL. Back in the days when there were still people alive who thought soap was a good idea. I ran across this idea, business process execution language. It was a giant XML spec, but it had the interesting idea of understanding that if you are coordinating across half a dozen different web services, something can fail. You don't have transactions across a system that distributed. The idea was to orchestrate calls between different services. And it had this idea of compensation action that I thought was fascinating, which was basically, we can't just call rollback, but if we get like 4 steps in and it fails, we probably can go and cancel at least a couple of the early steps. And it had that baked in as a core concept. And I thought that was really clever. Going back to -n. Oh yeah, here's a truly odd thing. Don't know if anybody's ever done this, but if you are at the point of, I need this thing to compile today, or problems are going to occur, I cannot figure out how to get the configure script to do the right thing. I am tired of this. I don't want to hand edit the make file. I still want a shell script to recreate what I'm doing. Make -n, pipe, Perl -pe, do an // to screw with the output to add compiler options, and then pipe it into sh is unbelievably useful. It's dirty, but if you document what you did, it can be the best way of getting something compiled today rather than having to come back tomorrow. This incidentally is why even though writing cross-platform make is horrible, I still hate module build, because module build hides away that logic in Perl code. So if you have a sysadmin trying to install something, they then run into the situation of, but how do I fix this now? I was amazed, actually. I thought module build might make a perfectly sensible solution for maybe complicated compilation on Windows. And I was at the German Perl workshop one year, and 3 German sysadmins stood up and interrupted me mid-talk. Germans stood up and interrupted me mid-talk. It was sufficiently important to them to say this. And I'm really glad they did, and their comment was, we are Windows sysadmins, and while yes, make on Windows sucks, we know how to debug it, please use MakeMaker. I think honestly, long run, somebody's going to need to write the equivalent of SQL abstract for make. Not it. Anyway. So in the process of wondering, by the way, I'm aware that this is kind of a long rambling thing of different bits and pieces. That's because it's been a long rambling journey towards trying to find ideas. I do promise you in the second half I will get to something approximating a point. But may not be a good point, but it'll be a point. Anyway, so Haskell. Okay, I have never actually successfully written a Haskell program. I will absolutely admit this. I'm sure there are many of us who've tried and not quite got there. At least with C code, I've now got to the point where I can reliably produce something that compiles and then immediately segfaults. Yeah. If you want to know why, and you know, Stephen even had a slide. Devil every day I'm segfaulting declare. Yes, I wrote the original C code for that. Yes, it's exactly as horrible as I'm making it out to be. I am incredibly glad that it demonstrated that keywords were useful enough that somebody competent implemented them in core. Anyway, but going back to the whole functional idea, okay, Haskell actually maintains purity, but can still do I/O. There was a recent article saying you should call it the IO type, not the IO monad, because otherwise people go away, try to understand monads, get stuck and run screaming, which I did about 6 or 7 times until I happened to watch a Haskell tutorial by Simon Peyton Jones, who, you know, GHC guy, genius. Also, academic background, good at teaching, successfully explained it to me. And for at least the next 10 minutes, I felt like I understood monads. Still can't write Haskell. But the basic principle of the way the I/O abstraction works is you make the world a parameter and a return value. So basically, you have a function that, say, prints a line. The way you keep it pure functional is it takes as an argument an old world consisting of the entire state of the universe beforehand and returns a value representing a new universe, which is exactly the same as the old universe, except in this new universe, the line has been printed. Brilliant. You know, if I was smart enough, maybe I'd be a Haskell programmer. Anyway, fantastic idea. And then from there, I fell over Prolog, which is the reason for the talk title, because Prolog is actually short for Programmation Logique, because it was invented by crazy French people in the 70s. But it's a fascinating idea. Prolog is a logic programming language. So it's all declarative, and it all talks about, go for an example. If you have a predicate, which is what you have instead of functions in yada yada, installed is your predicate name, server and package could both have values or not. So the idea is no. I thought I had another slide explaining that. I didn't. I'm stupid. Never mind. The idea is, if you say installed some machine, some package, it either says yes or no. However, if you say installed some machine and package is a new variable that doesn't currently have a value, it will give you a return, one return value per package on that server, and you end up with a package listing. You can equivalently call it with a package name, but no server name, and it will tell you all servers it knows about where that package is installed, which I think is a really interesting and powerful concept. Because the whole point is, what you basically do is declare a list of things that need to be true to have a valid solution, and then it goes through the different candidates it has and returns you combinations where those things are where all of those invariants are true, which is really interesting. If you're dealing with sort of scheduling stuff or similar, it's well worth having a look at Prolog, because they've been building insane scheduling systems and combinatorial stuff for, well, since the early 70s. And I will also point out, it's not the silliest name that has been inflicted upon me by crazy French people. The silliest name is that there's a theorem solver proof assistant that I started working with for quite a while. Started playing with. I've not. This is another one. I played with it. I never actually did anything real in it, but stole a bunch of ideas. But the proof assistant is called COQ. I am English. There is a slight disadvantage to saying, to going down the pub to talk to your friends, and I go, what have you been working on today? Oh, I've been learning cock. I mean, then again, Rafael Garcia Suarez did point out to me at one point that my initials also in French work out as mélodie sexuellement transmissible. So I guess basically the French language is trolling me back. But and then the other thing I ended up playing about with is TCL. Anybody actually written TCL? Yeah. Oh God, egg drop. Right. How do I put this? In the primary IRC channel for TCL, egg drop users are to that channel what people who had just discovered CGIlib.pl were to Perl channels 15 years ago. In that their problems are almost never anything to do with the language and everything to do with a certain level of being unclear on all the concepts. And also, Eggdrop has this wonderful habit of eating whatever the error message was. So usually the most help you can give to an Eggdrop programmer with a problem is to teach them how to do a try-catch and actually log the error message. At which point, the bug tends to become obvious. But anyway, TCL is kind of fascinating because it's basically Lisp but built out of strings. To the point where braces in TCL are actually a quoting construct. So if you see in TCL if condition block, the block is just a string. The way the if statement actually works is it only evals the string if the condition is true. This is not as terrible as it sounds because TCL was built to work this way. So basically, the internal value ends up getting tagged with the compiled representation, so you're not actually doing string eval all the time. But it meant, and this was the point at which I fell in love with TCL, because it took me about 5 lines of code to add unless. And I get upset every time I have to use a language without unless. I swear, one of the main reasons I fell in love with Perl, I think, is that my parents are both English graduates. So I have a certain love of language. And having to say, if not, just irks me. I still don't understand why the rest of the world doesn't have an unless statement. It just makes code so much nicer. Anyway, and okay, come back to, okay, yeah, Perl. You know, it's the Swiss Army chainsaw. It's new. I'm going to build it in Perl first just because I know I will be able to bend it to do what I want. I originally gave, okay, it wasn't this talk exactly, but this couple of slides was a Unix sysadmin conference, which meant the next slide really did confuse some of the audience. Because people were going, no, that doesn't make any sense at all. I'm like, well, okay, but that just means you haven't discovered Moose. Or, you know, Moo, my half-size cut rate knockoff of Stephen Little's work. And the fascinating thing is you then get a bunch of people going, it can't be that good. I'm like, well, if it isn't that good, why are people trying to port it to Ruby? There is a MooseX gem that provides a has statement in Ruby. Next time I try and use Ruby, I'm going to use the gem. I might actually not get put off by the shitty OO and be able to write some code. And even the Python guys have tried to port Moose as well. So, you know. I think it was people who had used Perl somewhat and then ended up on another language and went, fuck me, where are the features gone? And decided that in the grand spirit of open source, the answer was to steal the features. And I wish them the best of luck. But come back to Make. I did actually at one point seriously consider trying to do systems automation stuff that was driven at a top level by Make. I mean, I do it for small scale stuff all the time, but I meant like a complete system, because there's a thing called Make PP, which is a pure Perl implementation of Make. I was thinking, hey, maybe if I embed this and I go from Perl to Make to Perl to Make to Perl to Make. And then my dealer got in a new shipment of drugs that weren't tainted with whatever made me think that was a good idea. And also, I hate tabs. Tab characters can fuck off, die in a fire covered in bees. My editor has a tab stop of 8. I use 2 space indent. I hate 8 space indent. But if you don't have your tab stop set to 8, you can't source dive the Perl 5 core. Because, well, yes, we are now on Git. The Perl 5 core is a mixture of tab indent and 8 space indent. There is a part of me that would really quite like to write a script that goes through and just fixes up all of those commits. And then the rest of me goes, no, don't do that, don't do that, don't do that, it will hurt. Anyway, this is also a really important lesson in terms of the, when Stephen was talking about future backwards compatibility, the guy who wrote Make, he realized that tabs were a mistake. He realized it about 3 months in. The thing is, there were half a dozen guys in the same office as him already using it. And he didn't want to break compatibility for them. So in order to save those 6 guys rewriting their Make files, the entire world has suffered tabs for the rest of eternity. Possibly the wrong choice there in hindsight. Never mind. I think anybody who writes a piece of software that unexpectedly gets popular runs into this. I can think of several things that I did in DBIX class that in hindsight I should just have broken about 8 years ago, before like half the world was using it. Of course, you know, now my solution to this is all of the mistakes are my fault, but fixing them is Ribasushi's problem. Thank you. Anyway, but the debuggability of Make files is really impressive. And also, because you have the -n, it's predictable. It can tell you what it's going to do. Once it's going to do the right thing, you tell it to do it. And it keeps doing it. And which means that, you know, okay, debugging Make files is still annoying, but it's a lot better than a debugging cycle that is, one moment. Can somebody tell me, is this supposed to be a 40-minute slot or a 50? Anybody know? Sorry? Cool, that's what I was hoping for. Okay, so, you know, every time I try and discuss any of this stuff with people, because I'm talking to different language communities, the first question I get from most people is, you're using what? Because, okay, most Perl people don't really get TCL. TCL people definitely don't get Perl. Well. And then, as for the Prolog people, well, I mean, honestly, my first thought was, wait, there's still a Prolog community? There is. Hash Prolog on Freenode is actually relatively active these days. It's mostly people taking it at university, but there's some really interesting conversations that go on in there. Okay, this may be influenced by my having a pure maths background, but my thought was, what if I try and do configuration management around a metaphor of equation solving? So you start off with a set of goals. This is very much stolen from Prolog. So you might have a goal like web server running on system. So if it's up and answering port 80, that's true. If it isn't, that's false. And then, so what do you do to be able to solve an equation? You can expand it to a set of simpler equations. You can extrapolate values, and you can eliminate terms that are now obviously true. So web server running on system can be, okay, there is some type of valid web server type. We have a package of that, and the package is installed. Simple enough, right? So expansion takes that initial goal and rewrites it. So you end up with internally something like this, where it basically Jensens up names, so that your final solution is all unique names, because obviously having two variables called x is not going to work very well. Not when there are different x. So let's say valid web server types are Nginx and Apache. So at this point, you can extrapolate by selection of a choice. So what you do is you start by saying, let's assume we've told it to try Nginx first, anytime it runs into the need for a web server type. Okay, I still end up using, basically, if I need to stick something in front of an app server, I use Nginx. If I'm going to do anything complicated, I use Apache. This is not meant to be a particular value judgment on either of them. It's just, I've been screaming at Apache for 10 years, and I know how to scream at it now. But anyway, so you can say, we can make web server type valid by selecting Nginx as that value, right? So having done this, you can do a lookup. At this point, there is only one current package for Nginx registered in, which is obviously whatever your Debian mirrors have or whatever. So you can deduce that means that if the server type is Nginx, the server package is whatever. And then having done that, you check for installation. Assuming it's installed, you can simply eliminate that, and therefore you have a return value of server type is Nginx, true. As in, you get a set of bound variables that represent a valid solution. This can produce multiple results, because obviously there may be more than one valid solution depending on the situation. So if you have an expression like known server has a web server running on it, it will try each server that it knows about, and you will end up with a set of results of server is web 1, server is web 2, server is web 3. If it returns server is DB1, you know you need to go and slap somebody. So okay, that's still straight Prolog style. Prolog does all of this stuff really nicely. But what if it isn't installed? So at this point, you need a concept of an action. You need to actually install something, right? So you have an action along the lines of install the package on the server. Mutating the world underneath is not something that an equation solving metaphor really works very well with. Because, equation solving is against a static reality. The rules of pure maths do not change when you're halfway through writing your proof down. Okay, if you're doing pure maths at a sufficiently high level, that may not be true, but at the level that I got to, it's true. So, presumably the people capable of doing pure maths at that level would also have been capable of writing Haskell. So, Prolog is pure logic. So at this point it goes, what? Go away. And you end up doing something else. The idea I came up with is a concept of counterfactual realities. As in, you can say, this is false, but in a world where somebody had run apt-get install nginx, it would be true. So what you do is you then consider your solution so far against that possible reality. And basically see if the inferences are still valid. And you know, nginx is still a web server. And whatever the package name is still a package. But in this world that was exactly the same as our original world, except somebody ran the apt-get before we started, the package install goal is true. Which gives you an idea of elimination via action. As in, you hit a point where you would be stuck, but instead of just going, okay, failed, you basically go back, pretend you'd already fixed it, and then see if you can keep rolling forwards. So you end up with an action scheduled of an install. Notice that the install sits at the front before the solving starts, and now we end up with true as a result. At which point, if we actually run the action, we can rerun the same basic logical deduction thing on the new state of the world to check it worked. This is where I get my minus n out of it, basically, because I end up with a solution that is a list of actions required, and once these are done, this will be a valid solution. Which means that basically, it schedules us in the same way as make, when everything's already built, returns nothing to be done. We can go and verify, which means you end up with a system that doesn't have to trust itself. Slightly more complicated becomes producing complex data. So you basically have to do take the simplest hypothesis. So the simplest hypothesis for a dictionary is that it's an empty hash, yeah? And then you can add the members as you go along. Basically, you keep adjusting your hypothesis, check that that hasn't invalidated any of your invariants so far, and you end up with a result. The next thing is the system needs to be able to get information from the world. So the way I decided to model this is, obviously the sensible solution here is to tie a hash. Anytime you think that, it's, anyway. But no, the idea is you can have a hash for is something a file, and when you look up the value of a key, it does the moral equivalent of a hash ref lookup, and that then goes and does the stat call. So that allows the system to get additional data in as it's going on, things like installed packages and whatever. So basically, observations check the current state of the universe, actions alter the state of the universe, and then the solver has to say to the action, tell me what you think is going to happen when you're run. So it will go, you know, if it's an install package, it will say, well, what I think is going to happen is the package is installed. When you actually run it, it doesn't just record the package is installed, it records the state of whether the package is installed has changed, which then forces it to go back and recheck. Which means that if you had an installation command that returns true, but didn't actually install the thing, the system will still be able to notice, which I think is actually really important. I don't want, if this thing is going to be running around as root on my servers, I don't want it to trust itself. It was written by programmers. So, yeah, I've got a couple of minutes left. A possibly more obvious example. So you start off with a dictionary that gives you the pause index, which is basically populated by ripping data out of the packages.details file. By the way, if you can half remember the name of a CPAN module, doing a grep on your cpan.pm's 02 packages file is really helpful. I refer to it as ghetto cpan search. And then you can do the same thing for meta info. So you end up with an observer that uses cpan meta to pull the data in. And then you can start doing interesting things. So this is basically an expression of dependency resolution. So you start off with this disk bound, looks up the requirements, goes through, and then recurses into itself, and you end up at the end with need disks being a hash that basically contains all of the things you're going to need to install to get your dependency solved. Okay? So, I mean, that's neat, but if you then consider the existence of a pre-built tarball that's basically a local lib of just that module, you can have an action for stuff that assembles that tarball, and then you attach that to a dictionary. So basically, in order to make, do we have a build of this true, it goes and compiles it. At which point, you add one line of, we need to already have a build of it, and this the system is then capable of not only solving the dependencies, but scheduling actions to do the relevant cpan installation of everything that isn't already installed. So you end up with a list of build actions to run, and then a final set of distributions. Dependency ordering doesn't actually have to be done particularly because it's implicit. Because of the way this thing is recursing down, it schedules the build of the dependent thing before the thing that depends on it. And I put all of this together, hit the go button, and it actually managed to recursively build all of the dependencies for Mo. So I consider that to be a validation of the concept. Naturally, this being, something of a research project, I then went and rewrote the entire thing from the ground up again. And so I don't immediately have anything fantastic to show you. So it's not a working cpan client yet. If I'd had maybe 2 more days hacking time, it probably would be. But it is going to be. And the solver concept, the idea of basically pure functional Prolog with the monadic I/O built in, actually works. If you keep an eye out, I will be blogging about this as soon as it turns up. The goal of the initial release is going to be something that has the same features as Carton install, but uses pre-cache builds. So once you've built something once, the install process is basically just untar these into a local lib. Welcome to FOSDEM, the conference where everybody is saying, I am going to have something working sometime this year. And mine is sadly the least impressive of the things that are being promised. But this is actually going to work. Keep an eye out. I will hopefully ship a 0.1 sometime in the next couple of months. And once I've done that, I'm going to be moving on to starting to go back to the systems automation side of things. But the thing is, I decided to do dependency resolution first, because what's the use of a configuration manager that can't manage its own configuration, right? So we're in the land of, hopefully this time next year, I'll be talking about running it as root and having it tweak configuration files as well. In the meantime, thank you for listening.